All right, kiddies, last video here for chapter 6. Today we're going to talk about solving systems of inequalities. Okay, so this is going to take us back a little bit of review. One thing we kind of struggled with a little bit, but talking about inequalities versus equalities. So we're not going to be looking at equations, but now inequalities. So let's take a look at these. Okay, in this section we're going to take a peek at solving systems of linear inequalities. So this is going to be different than in linear equations, because obviously equations we use an equal sign. Now today we're going to look at inequalities instead. It's going to be kind of the same thing that we did in the first section. We're going to talk today about graphing linear inequalities and solving these inequalities through graphing. Okay, but what we have to do first is kind of take a look back and revisit what does an inequality mean. Now, a system of inequalities, again, we're still going to have two inequalities here with x and y. The only difference is that we're not going to have an equal sign. Instead, we're going to have our inequality sign. So let's take a look back at some of our inequalities that we discussed back in chapter 3. So there are 4 inequalities that we have. First, we have less than, greater than, less than or equal to, or greater than or equal to. Okay, now, again, why do we use inequalities? Well, inequalities, again, are describing things. Inequality means not equal, so describing things that are not equal to each other, but then giving them a certain description. Like, for example, I know, 3 is not equal to 2. Well, instead of just saying they're not equal, I can describe it a different way. I could say 3 is greater than 2. I could say 2 is less than 3, and so on and so on. Okay, so it's just a different method, again, on how we describe two things. Okay? Now, one thing we talked about too with inequalities is being able to represent an inequality on a number line. Now, we're going to be graphing inequalities today, so it's going to be a very similar discussion that we had when we talked about putting inequalities on a number line. So the first thing, if I were to just plot, let's say, y equals 2. Okay, if I know that y equals 2, I can plot that on a number line. So again, on my number line, let's choose some values. I'm going to choose some values above and below 0. Okay, so I have from -3 to 3. And I want to represent y equals 2. Well, y equals 2, I'll do this one in blue. Basically, to represent that, we would just put a point or a dot at 2. Closed dot saying, well, hey, that's why y is equal to 2. Now, instead, if I were to represent an inequality and say y is greater than 2, remember what we do here. When I say y is greater than 2, I'm not saying it's equal to 2, but I'm saying y, whatever that number is going to be greater than 2. Well, think of some numbers that are greater than 2. You have 3, 4, 5, and so on and so on. So the way to represent these is we're not going to represent the value of 2, so we put an open dot there, but we want to represent any number that's greater than 2. So the way we do that is by putting an open dot and an arrow pointing to the right. Basically what this is showing that we're looking at any number that's not 2 but is greater than 2. So equations, we're talking about two things that are equal. Inequalities is a comparison between two separate quantities. And our goal for today is being able to look at a system of inequalities that contain x and y within it. So what we're going to get is we're going to get really two inequalities in one. We're going to get x is greater than, less than, greater than or equal to, or less than or equal to. And we're also going to get y is equal to, or sorry, not equal to, less than, greater than, less than or equal to, or greater than or equal to. So we're going to get really two solutions again like we did before, but describing x and y. All right, so let's take a look at these two examples. So what we're going to do here is I'm going to give you a system of inequalities, and our goal is I'm going to give you a point of x and y. And our goal is to determine, is that point of x and y a solution to our system? So again, a solution means it's going to satisfy both equations, and in this case, it's going to satisfy both inequalities. So here's what we do. Notice here I have a point of 2, 0. So what that means, 2, 0, again, 2, 0 tells me that my x is going to be 2, my y is going to be 0. So from that we can see, okay, x is 2, y is 0. Now, with this inequality, notice I have a system of inequalities. Y is greater than or equal to 2x, and y is less than x plus 1. So I want to see if this point of 2, 0 satisfies this system. I want to know if it's a solution. So all we have to do is we're going to take this point of 2, 0, and we're going to plug it in to each inequality. Okay, I'm going to do the top one here in green. So my inequality is y is greater than or equal to 2x. So what I'm going to do is I'm going to plug in x and y. Well, I know y is 0, and I know that x is 2. So the question is, okay, what's 2 times 2? The question is here, is 0 greater than or equal to 4? Well, looking at that, we know that is not true. So that does not work. Okay? Let's take a look at the second one. So I'll do this one in red. I have y is less than or equal to, less than x plus 1. So plugging in my value of x and y, I know y is 0 and I know x is 2. So 0 is less than 2 plus 1, which is 3. Does that work out? Well, this one does. So notice how my point here satisfies the second inequality of y is less than x plus 1, but notice that it doesn't satisfy the first inequality. Okay? So is this a solution? This would not be a solution. Why? Because it does not satisfy both inequalities. So with inequalities, again, we still have the same idea, a value of x and a value of y, but instead of being equal to, we now have these comparison symbols of less than, greater than, and the other two that we have. Okay, I want you guys to take a second right now to do example 2. So I want you to try example 2. You have a point of 2, 1, and you have two inequalities. Y is less than negative x plus 4, and y is less than or equal to x plus 1. So again, your x is going to be 2, your y is 1. What I want you to do is take these values of x and y, plug them into each inequality, and tell me whether or not this point is going to be a solution to this system of inequalities. Okay, so I want you to pause the video, practice right now with this problem, see if you can get it correct. All right, so let's test your solution here. So again, I had the point of 2, 1. Two inequalities, y is less than negative x plus 4, y is less than or equal to x plus 1. Again, I took my solution of x and y. I looked at 2 as my x, 1 is my y. Took each one, started with the first one I did in green, all right, plugged in. Here's my inequality. I plugged in 1 and 2 for x. Notice here it's negative x, so I plugged in negative 2. Negative 2 plus 4 is 2. So I found out, it says here, think about what the inequality says. 1 is less than 2. Well, hey, that makes sense. 1 is less than 2, so yes, that works out. Second one, y is less than or equal to x plus 1, less than or equal to. So I want whatever's on the left to be less than, or it could be equal to. Or means it's one or the other. Okay? Plugged in 1 and 2 again for x and y. Y goes there, x goes there. 2 plus 1 on this side equals 3. So I have 1 is less than or equal to 3. Well, 1 is not equal to 3, but it certainly is less than. So this ends up working out. So notice here that my solution of 2, 1 satisfies both inequalities. This is considered a solution. All right, so now let's talk about how we actually graph inequalities. So the last examples, I gave you kind of a test point, and I said, is this a solution? And one, we had to plug it in to figure out if it's a solution or not. So what we're going to look at here is, what if I give you a system of inequalities, and I say, find a solution through graphing? Okay? Now, to graph inequalities, we've got to talk about this first. How do we actually graph inequalities? Well, this is kind of easy. When I graph an inequality, I'm really going to graph it the same way as a line or as an equation. Okay, so if I give you, for example, this equation, y equals 2x plus 2, that's an equation because we have the equal sign. But I can also write this as an inequality and say instead now y is greater than 2x plus 2. Okay, so what this means, whatever values of x we have here, when I plug this in, it should be, this y value should be greater than whatever this right side turns out to be. Now, how do I actually figure out what a solution is from there? Okay, well, first of all, let's talk about graphing this. Okay, so when I graph this, here's what I'm going to do. I'm going to graph this just like a line. Now, when you look at the equation here, you would obviously see, okay, my y-intercept is 2, and my slope, the number in front of x, is also 2. So I can easily graph this. Now, when you look at the inequality, I have the same thing. The number in front of x is still my slope. Nothing changes there. So my slope here is still 2. Remember that as a whole number, that is 2 over 1. Don't forget about that. Okay, then b, my y-intercept is still 2. So I can easily graph this. Now, to show you this, I'm going to plot points. So I'm going to plot my first point of 2. That's my y-intercept. Again, I went 2 on the y-axis. Okay, then I'm going to apply my slope of 2 over 1. That means up 2, right 1. I run out of space going up and to the right, so what I'm going to do is draw my points going down. Now, quickly guys, hold on for a second. Before you actually go ahead and draw the line, let's leave the points. Okay, so I'm going to plot the points. And here's what we're going to think about. Normally, with equations, we would just simply draw the line and be done with it. However, now we have an inequality. So there's a couple things I have to think about. what does a solution to this mean? What does it mean to be y is greater than 2x plus 2? Well, here's what I want you to think about. I'm going to choose 3 points, okay? I'm going to choose a point above the line. So I'm going to choose this point of, let's see, it's negative 3, 2. I'm going to choose a point on the line. I'm going to choose this point right here, which is negative 1, 0. And I'm going to choose a point below the line. Let's make an easy one. I'm going to go 1, 0. Okay? So I'm going to choose these 3 points. And what I'm going to do is plug each of these points into my inequality. Let's see what happens. So when I plug in the point, let's start with above, negative 3, 2. Okay, let me do it in green down here. When I plug in negative 3, 2, I'm going to plug in 2 for y, and I'm going to plug in negative 3 for x. So let's see what we get. Well, on the right side, 2 times negative 3, this is going to be negative 6 plus 2. I'm going to get 2 is greater than negative 6 plus 2 is negative 4. Well, 2 is greater than negative 4. Hey, that makes sense. That checks out. So that works. So that would mean this point right here would be a solution. Okay, let's check a point on the line then. So a point on the line is negative 1, 0. Let me do this one in blue. So if I choose negative 1, 0, I'm going to plug in 0 for y, so that's going to be y is greater than 2 times negative 1 plus 2. Well, let's see what we get here. 0 is greater than 2 times negative 1 is negative 2 plus 2. Well, I get 0 is greater than, well, hey, 0. Well, let's think about this. Is 0 greater than 0? No, 0 is actually equal to 0. So this doesn't work. What that means is that this point on the line is not a solution. This does not end up working out. Okay, we'll talk about that in a second. And then the last one was choose a point below. I'll do this in green. So I'm going to take this point of negative 1, 0. Let's plug it in. So I'm going to plug in 0 for y is greater than 2 times 1 plus 2. 2 times 1 is 2. So I get 0 is greater than, 2 times 1 is going to be 2, plus 2, that's going to give me 4. I'll do that one quick. So 0 is greater than 4. Well, obviously, by looking at that, we know that this is not true. So what we end up getting here, let's take a look at our 3 things, our 3 points. When I chose my point above the line, negative 3, 2, notice how my inequality worked out. When I chose the point on the line, it didn't work out. It didn't make sense. It should have been equal to. Okay, and when I chose a point below the line, it also didn't work out. So that means when I have this inequality of greater than, points above the line are actually points that are a solution. On the line, no, and below the line, no. So how would I represent this as a graph? So I can't represent points that are on the line, so what I'm going to do is draw a dashed line, because that really represents the barrier. Okay? It's not really saying dash, I'm running a dashed line because it can't include points on that line. It can't include points below the line, but it includes points above the line. Okay? Now remember when we had a number line, we drew an arrow to represent all those points. Instead of an arrow here, what we are going to do is let's shade in the region. So I'm going to shade in everything above that line, because really any point that falls in that shaded region that I shaded here in yellow is going to represent the solution. Okay, a little different here. All right, so now let's take a look at the rules. So here's kind of what I did. Basically, I put my slope and my line in slope-intercept form and graphed it just like I normally would. Okay. Now here's the kind of the key thing. I did an example here of greater than. Anytime you have less than or greater than, that's without the equal sign, you are going to draw a dashed line. Okay? And when I have less than or equal to or greater than or equal to, anytime you have the equal to that's included, my line is going to be a solid line, because think equal to, that would satisfy this one right here, the one that's equal to, that's on the line. So that one would end up working out. In this case, it doesn't. Okay, so solid line for the equal to's and dashed line for the not equal to's. And then I'm going to shade depending on my test point. Here I chose a test point above. Okay, and you'll kind of get the hang of this. Things that are greater than are usually going to be above. Less than is going to be below. Okay, so you'll kind of get the hang of that. So that's our goal for today, is now being able to graph inequalities. All right, so here we go. 3 more examples. I'm going to go through the first one with you guys, and then I'm going to have you guys do example 4 and 5. I'm going to have you pause and do 4 and 5. So let's go through example 3. So example 3, we have y is greater than 1/2 x minus 2. Y is less than or equal to negative 2x plus 3. So again, I'm going to graph these just like I would lines. I'm going to do the first line in green, second one in blue. So let's start with the first one. So graphing like a line, I see minus 2. So my y-intercept is minus 2. I'm going to plot that point. Then apply my slope, which is 1 over 2. So 1 over 2 means up 1 over 2, up 1 over 2. I'm going to draw multiple points. Go in the opposite direction. I'll go down 1, left 2, down 1, left 2, and so on. Now I notice this inequality is greater than. Okay, so greater than, what I'm going to do, it's not equal to, greater than, so I'm going to draw a dashed line through those points. Okay, then greater than, again, is going to represent anything that's above. That's going to be anything above this green line. So I'm going to shade that above there in yellow. Okay, then let's do the blue line. So the blue line, I have negative 2x plus 3, so I'm going to go up 3 for here. Then remember, my slope here is negative 2. So remember, negative 2, that's going to be, sorry there, kind of sloppy, negative 2 over 1. So that means I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, and down 2, right 1, and so on. Okay. Now my inequality here, is less than or equal to. Now this one, because we have the or equal to, I'm going to draw this as a solid line. So that's the difference. When it contains the equal to, I can say that any point on that line is a solution. Okay? Now this one, we also have less than. So equal to means draw the line. Less than means I'm going to shade any region or all the region below. So I'm going to do this in kind of a light pink. So any region below. Okay? So I shaded the region below. Now what I want to do is find a solution to the system. So I'm going to choose a point. Now to think about a solution to a system, you need a value of x and y that doesn't satisfy one inequality but satisfies both. So looking at this graph, I look at, okay, this region right here. Okay, this region in this enclosed area. Notice how the pink and the yellow shaded region overlap. Okay, well, I'm going to choose a point in that region. So I'm going to choose this point right here. Okay, I'm going to do this in red so you can kind of see it. So that point right there, well, what is that point? That is a point of negative 3, 0. Okay, now, is that a solution to the system? I'm going to do this kind of quickly. So plugging these in, the first one I get 0 is greater than 1/2 times negative 3 minus 2. Okay, so I got 0 is less than, well, I'm just going to do this as negative 3/2 minus 2. Well, if you look at this one, all right, negative 3/2 minus 2, okay? Just think numbers-wise. You have a negative number minus another negative. You're going to be more negative, even though this is, yes, a decimal. So what ends up happening is this is actually going to be this is going to be true because 0 is going to be greater than that negative number. Okay, then if I choose the other equation and plug in 0 and negative 3, I would have 0 is less than or equal to negative 2 times negative 3 plus 3. Well, this gives me 0 is less than or equal to 6 plus 3. Well, that's 0 is less than or equal to 9. Well, hey, that's also true. So notice how this point of negative 3, 0 is a solution. So what we did is we looked at this point where we have a shaded region that's shaded by both, and any point, and I chose one of them, any point inside that solution or inside that region represents a solution to the system. Okay, so we're going to apply the same principle then, the same idea, to examples 4 and 5. So right now I want you to pause the video. You're going to be graphing numbers 4 and 5, drawing each graph. Careful, number 5, notice the second equation. You've got to simplify a little bit there. All right, and then what you're going to do is graph them and choose a point that would represent a solution. So pause the video now and get a head start on those. Ready, set, go. Okay, let's take a look at examples 4 and 5, starting with example 4. So you'll see I graphed the red line here. Y is less than 2x minus 3. Okay, plotted my y-intercept, applied my slope. Dashed line because it is only less than, is not equal to, and I shaded the region below that line because it is less than. Okay, next one, y is greater than 2x plus 2. So here, green line, dashed line again because it's only greater than, not equal to, and notice I shaded above. You should notice one thing if you remember back to the last section, we have a slope of 2x and a slope of 2x, or a slope of 2 in each of these lines. So we know these lines are going to be parallel. Now, because of the inequalities, notice that the fields that the space that I shaded in for the green and the red, notice how they don't overlap. So the question is, do the two things have a point in common? Well, if they don't overlap, here you'll see that there is no solution. There is no unique point there's really no point at all that these two inequalities would have in common. So in this case, we have no solution. Taking a look at number 5, however, number 5 required a little bit more work. If you can see it clearly, the one in green, we have y is greater than x minus 7, so I applied my y-intercept of minus 7, slope of 1, remember the number in front of x is 1, dashed line because it is only greater than, not equal to, shaded above because the inequality says greater than. The next line, 3x plus 6y is less than or equal to 12. That one I had to get into slope-intercept form first, so I showed the work here, subtracted 3x to the other side, then divided everything by 6 to get my y is less than or equal to negative 1/2 x plus 2. Be careful with these types of problems when you get to your practice because you'll find some things you have to remember about inequalities. But looking at this, I graphed the red line. It's a solid line now because we have the equals to. It's less than or equal to. Okay, so the solid line and that's shaded below. You'll see I highlighted in yellow. Okay, this region right here, any point in that region would represent a solution. So I just chose a random point. Negative 2 is my x, y is my negative 1. And again, what I would want you to do here, I just kind of skipping over that, but this right here I'd want to check, and if I did it like I did in example 3, I would see that this would be a solution. All right, this concludes the video. Last video of this chapter. Hope you enjoyed. We'll see you in class.